Alright, Chapter 1. Chapter 1, Neat Module 16, Chapter 1, Part 2. I had to cut the tape because I thought I lost I thought the microphone was not plugged in, but I tested the tape. Electronic measurements involve the fundamental electronic quality of voltage current, they inherit with the character of the resisting capacity and inductive, the trick of the temp of the voltage current with the depend with the resistant capacity and inductive of the distribution. Therefore, the voltage current with the branch with the valuable aid to determine the circuit component with the condition for the intervention with the evaluation with the shift of the practical aim with the reading of the time with the U with the test equipment will depend on these paper the measure of quantities, resistant capacity, the inductancy, voltage current measure. The voltage measure made with the may be made with the power of the U that prevent with the corrective measure the measurement made U with the volt made with the compare with the voltage chart with the measurement with the variable aid located with the trouble quickly easily. However, the sensitivity of the test voltage with the voltmeter different with the voltmeter U with the preparing chart with the voltmeter measure with the most value would before the turning the true circuit the condition that began to be determined. Sensitivity and voltmeter with the discovered in the East Module 3 with an introduction circuit protection control measurement to see many with the trouble to find with the equipment system as a result of the abnormal voltage of the voltage measured with the measurements of the with the locating trouble to measure with the voltage of the voltmeter without interpreting the circuit operation. Point-to-point voltage measured with the chart for the usually found the equipment technical main with the name of the normal operating volt for the various state of the equipment voltage of the usually measured with between the indicating point of the ground and left of the otherwise state with the reading recorded voltage remember the smart and state with the practice of this voltmeter high with the range before the measuring and ensure the excess of the voltage excess of the existing in the circuit will not cover the overloading of the meter. To improve the accuracy, you should then set the voltmeter with the proper for the correct voltage with the voltage check. Start the check voltage if the remember the voltage reading they obtain with the curve of the resistance even with the resistance open the resistance of the meter is self forms the current resistance of the meter probe within place within power curve of the up open resistance. Therefore the voltage curve of the component of the may appear with the normal to near normal as you read the meter with it, but actually may be abnormal with the meter disconnected from the circuit. If the internals of the voltmeter are approximately the same with the resistance being tested, they indicate with a considerable lower voltage than the actual voltage present in the meter to remove from the circuit. The sensitivity in the meter per volt with that voltmeter you with the provider with the voltage chart with the provider with overloads on the chart. The meter with a similar sensitivity available should you with reduce the effect of the loading. Alright, the following precaution general safety branch for the apply with the measurement of the voltage. Remember that nearly all voltage is danger for the have often provided proved with the fatal to care of the technician when measuring the voltage of the be observed with the following precautions. So, the test equipment of the highest range measure be sure make sure for the safety observe the downside of secure power with the equipment understanding the connect of the ground lead with the voltmeter first. You have the only one hand with the take of the measurement of the hospital bullet, the other hand in your pocket or behind with your bracket. If the voltage measured with less than 300 ohms, 300 volts, plate at the end of the test probe on point to point to be tested with the polarity switch with the select the positive and the negative readings. If the voltage is to be measured with more than 300 volts for the proceed, valve the shut off the circuit power with the discharge and discharge all the fill capacitor short probe with the template around with the point to be measured for the negative clip on the proper tip of the lead with a high voltage point. May move it away from the voltmeter, turn the circuit power and read the voltmeter. They turn off the circuit power discharge with all the capacitor before disconnecting the meter. Alright, your current measuring after are now often taken in some of the preventive testing. This is because of the aim of the often the current of the measuring instrument must be covered the actual part of the current equipment that being stored with the circuit must be open to desoldered but the connect with the ammeter to ensure the circuit being tested usually can be taken advantage of the measurement that you the factor calculate with the circuit current by applying the Ohm's law. Resistance measurement. The resistance measurement available to aid to locating the effect of the circuit component during the corrective maintenance handbook. The equipment that can often be helpful to take these measurements. The handbook can often contain resistance chart for the reference of the acceptable test points. While the equipment while these charts are taking the resistance measurements in the complex circuit is slow. The process is slow because one type of the circuit component must be often to be decided to get the true resistance measurement. However, the resistance tolerance wherever there should be widely approached the resistance reading with the adequate. For the most jobs, one of the most successful test points found with the ammeter is with the take of the resistance measure. Because of the degree of the accuracy and of the ammeter, with the proper calibration, understanding of the meter scale is a must. Topic 2, the module will be discovered the requirements in the detail. While using the ammeter, you must observe the following crossing the circuit being tested that must be completely de-energized. Any meters, transistors which could be damaged with the ammeter current that must be removed before any of the measurements are made. Capacitance measurement. The capacitance measurement is usually taken with the capacitance meter, but the capacitance tolerance varies even when widely with the resistance with tolerances. Capacitance tolerance depends on the type of the capacity, but the value of the capacity, the voltage rate, and the actual measurement of the capacity varies. Simple, however, they must take the important decision whether to reject or continue. Use the capacitor after it has been tested the power factor with the capacitance with the important pack because of the indication of the various law for the capacitor, the power loss can be trained. Trace in dielectrical such with the current leakage of the dielectrical absorption. Current leakage is considerable importance, especially with electrolytic capacitors. Inductancy measurement. The inductance measure seldom required for the course of the troubleshooting. However, the inductancy measurement is useful in some cases. Therefore, the bridges discovered in the next section are available for making the tests you find with many of the capacity tests that can be made. Can be used with the measured inductancy mode of the capacity tests are furnished with the inductancy conversion chart to test the equipment scale and not calibrated to read the value with inductancy directly. Our capacity and inductancy resistant bridges. You measure the capacity and inductance resistant to specialized action for the U of the AC bridge of the bridge over the capacitor and inductor resistant to the wide variation of the combination of the bridge of the operator with the principle of the DC bridge for the Wheatstone bridge. The Wheatstone bridge for the U of the precision measure for the resistance for the circuit diagram of the Wheatstone bridge is shown in figure 1.5 with the resistor 1, 2, and 3 with the precision variable, the resistor available air resistance with the resistance resonant resistance. Unknown resistances must be determined. The bridge that then probably with the galvanometer G reads 0. The reason for determining mean for the simple form of the galvanometer of the instrument that measures the small amount of the current inserted with the cross of the terminals B and T and can indicate the condition of the balance when the bridge of the properly balanced with no difference potential cross exists between B and D with the switch 2 S2 is close with the galvanometer reading at 0. Our this show of the Wheatstone Bridge circuit, resistors 1, 2, and 3, resistor X, voltage 1, 2, and 3, and 4, voltage X, amperes, and switch 1, negative positive of the battery 1 battery cell. Operation bridge is explained with a few logical steps of the battery. Switch 1 is closed with the collection of the negative terminal of the battery to point A. Here the current divides itself within a parallel circle. The part of the parallel with the resistor 1 and resistor 2 remains with the resistor 3 and resistor X. The two comparison I amperage 1 and amperage 2 with the unit with the point C with the return of the power of the terminal of the battery value amp 1 is dependent with the sum of the resistor resistance of the resistor 1 and 2 amp 2 is dependent with the sum of the resistor 3 and resistor X or resistance X, which we're trying to find. Alright, in each case according to the Amps law the current is inversely proportional to the resistance and resistor 1, 2, and 3 adjust the switch 1 and when the switch 1 is closed with no current through the galvanometer with the galvanometer with the node flexing the difference with the percentage for the point of B and T with the amp 1 follows ABC path and amp 2 follows with the ABC path with the being with the voltage with the drop of the voltage 1 across the resistor 1 points A and B is the same voltage of the drop of the across the A voltage 3 across the resistor 3 between A and D with the similarly though for the voltage drop of the resistor 2 and the resistor X the voltage 2 and voltage X are also equal to expressed algebraically. Voltage 1 is equal to voltage 3 amp the 1 resistor 1 is equal to amp 2 the resistor 3, so the amp 2 is equal to amp voltage X, amp 1 times resistor 2 is equal to amp 2 times resistor X. The information you can figure with the value of the unknown resistor X, the value of the voltage drop across the resistor 1, resistor 3, respectively the voltage drop of the resistor across the resistor 2 and the resistor X. Amp 1 resistor 1 over amp 1 resistor 2 over equals amp 2 over resistor 3 over amp 2 resistor X. And you can simplify the equation resistor 1 over resistor 2 is equal to resistor 3 over resistor X. We multiply the both sides of the expression by the resistor X. The resistor X is equal to resistor 2 times resistor 3 over Rx. For example, the one figure from the known with the resistor 1, 60 ohm, with the resistor 2, 100 ohms, resistor 3, 200 ohms, the value with the resistor X, we can formalize this for with the resistor X is equal to resistor 2, resistor 3 over the resistor 1. So that Rx is 100 times 200 over 60, the 260. 20,000 over 60 gives you 333.33 ohms, remaindered ohms. Uses AC bridges. A wide variety of the AC bridge circle the stuff of the Wheatstone may be due with the precision measurement of the AC with resistant capacity and inductance. You look at the AC bridge and determine the function of the resistant bridge and AC signal generator shown figure 160 with the source of the voltage current of the generator path of the resistor 1, resistor 2, the known with the ratio of the arm of the resistor S and resistor X. The resistor X is known with the resistance of the resistance S is the standard value of the replace with the resistor replaces resistor 3 with the figure 1/6 the voltage drop across resistor 2, the resistor S are equal. The voltage drop across the resistor 2 and the resistor X are equal. Also equal to no difference potential across the meter with no current flow through it. As we discovered the Wheatstone bridge with no voltage appear with the across the meter, found the ratio is true. Show the figure 1/6 for those resistant bridge AC. The resistor S is known as an adjustable rheostat with 1, 2, and 3. Resistor X is unknown. There is a generator. A single AC signal generator switch. For example, the figure 160 over the resistor 120 ohm, the resistor 240 ohm, the resistor S for 60 ohms. You can find the value of the resistor X using the following formulas. Resistor X is equal to resistor 2 times resistor S over the resistor 1. Rx is equal to 40 times 60 over 20, 2400 over 20 with equal to 120 ohms. When the AC signal is applied with the bridge of the resistor 1, resistor 2 vary with the rear 0 reading with the same with the divinity with the 0 deflection equal to the bridge is man with the note. The actual prints back to the variance variables are just the minimum reading sense of the phase of the difference between the two legs will not always allow with the 0 reading. Capacity bridge because the current varies inversely resistant directly with the capacity inversely proportional with the existence of the form of the bridge and the figure of 1 5 and 1 top of the bridge side with the expression inverted with the resistant bridge expression as follows. Resistor 1 over resistor 2 is equal to capacitor X over the capacitor S. Capacitor X is equal to resistor 1 times capacitor S over the resistor 2. Show the capacitor, show the capacity bridge. You have resistor 1 capacitor S X on RS standard resistor S on standard unknown side of those the motor is resistor 2 resistor X capacitor switch 1 and your generator. Resistor 1 is the same with the equation with the resistor 1 resistor 2 simple multiplication equation with the capacity X. It will be the same with the capacity S, farad, microfarad, and so forth. Simplifying with the following resistance ratio that exists between the form of the bridge and the resistant bridge expression is earlier. Resistor 1 over resistor 2 is equal to resistor S over the resistor S over resistor X. Resistor X is equal to resistor 2 times resistor S over the resistor 1 for both unknown resistant capacity. Resistor X and the capacity X can be estimated with the terms known by the unknown resistor 1, resistor 2, resistor S, and the known capacity of the capacitor S. Figure 1 for example will show the resistor 1 with 20 amp, the resistor 2 40 amp, the resistor S 60 amp, the capacitor S 10 microfarad with the capacitor X with the resistor X with the respective formula. Capacitor X is equal to resistor 1 over the capacitor S over the resistor 1 capacitor X is equal to resistance 1 times capacitor S with the resistor 2 with the capacitor X is equal to 20 times 10 with the 40 with the capacitor X with 204 hands 20 to 4 20 over 40 with gives you 5 microfarads. Resistor X with the equal to resistor 2 with the resistor S over the resistor 1, which will give you 40 times 60 over the 20 with 240 and 2400 over the 20 with the 120 ohms. Inductancy bridge. The value of the unknown of the inductancy is the inductive and the known inductancy may be determined by the mean of the simple bridge circuit with the shown with the figure 1/8 ratio of the arms of resistor 1, resistor 2, actual bridge, calibrated resistor, standard inductor with its known with the inductance resistor S. The RS is known with the resistance. RX is representative of the resistance of the unknown inductor. This show of the inductancy bridge. Show of the switch 1 on the left side of the motor. You have your resistor 1 adjustable rheostat, inductancy LS and resistor LS standard. Your resistor 2 is known and RX and LX is resistor X and inductor X is unknown. The AC signal is applied with the bridge of the variable resistor 1 adjustable minimum with the 0 deflection meter according to the condition of the base amount of the bridge of the balance with the following form may be with the inductance the find LX. The right side of the expression not inverted will be was in the capacity of the bridge. Resistor 1 over the resistor 2 equals the LS over the LXL. RS2 over the LS 1 times LS over the resistor 1 equals the LX. Resistor 1 over the resistor 2 equals the RS over the RX. RX equals R2 times RS over the R1. In figure 1A, for example, the value of the resistor 1, resistor 2, and the RS are 20, 40, 60 ohm, respectively, with the LS. The induction LS is 10 millihenry. That you can find with the value with the RS and the LX value of the representative of the formula foul. LX over the resistor 2 with the LX over the R1, so that gives you 40 times 10 over the 20 with the 400 over 20, that gives you 20 millihenries. Alright, resistor X equal to resistor 2 with the times RS times divided by RS1, gives you 40 times 60 over the 20, 2400 over 20 gives you 120 ohms. In both unknown resistive inductance can be estimated with the term of the known value with the resistor 1, resistor 2, RS, and LS. Alright, summary, chapter 1.